Guten Tag, my name is Wolfgang Beetz. I'm with Maxwell Technology, based in San Diego, California, the US. And I'm here to talk about the ultracapacitor retrofit for pitch systems. And before I start, I would like to take a quick survey in the audience to see who is here from wind turbine OEM. If you can raise your hand, maybe. Okay. Anybody here who is working for wind farm operators? No? Okay. So Maxwell Technologies is based in the US. We have offices around the globe to support our local customers. We have many different applications reaching from automotive applications all the way through renewables to wind pitch applications. And if we talk about wind pitch applications, today we have about 54,000 turbines running, relying on our Maxwell ultracapacitor technology for the pitch backup system. And you can see on this side over here we have the product offering, the standard product offering. And now we also have an aftermarket solution for turbines that are deployed and running with batteries, where operators would like to retrofit batteries with the ultracapacitor solution for longer life and improved operational performance. For the past 15 years, we have been working with a complete wind pitch supply chain. So we are working with wind pitch design houses, we are working with manufacturers, we are working directly with OEMs, and we are also working with the wind farm operators and who maintain, or independent service provider who maintain and provide service to wind asset owners. And here's just a small selection of different customers we have been working with over the past 15 years. If you look at the wind pitch technology, what happened over the past years, and these numbers come from the Navigant report, they typically list the top 10, the install base of the top 10 OEMs globally. And if you take a look at these numbers, you see a trend towards the ultracapacitors used in pitch systems. So about 43% today the installation have been done with ultracapacitors. 37% is a hydraulic-based pitch system, and 20% is using batteries. And since the early 2001, when we deployed our first ultracapacitors in wind pitch systems, this trend has been moving steadily from battery-based system to ultracapacitor systems. And the reason for that is very simple, because if you talk to the wind farm operators, they have a lot of issues using batteries. Some sites, they have battery acid leaking into the EPU. It causes corrosion, it causes collateral damages in the EPU system. They have a short lifespan. Sometimes they have to replace batteries between 2 and 4 years, every 2 and 4 years. And there's a big safety concerns for some of the operators, because every time when they have a battery fault condition, they have to send up a technician up to the tower, into the hub, to check what's going on. Do I have to replace the battery? Is there some other issues that I have to take care of? And so there's a lot of technician time spent to check on battery fault conditions. And not to talk about the confined space issue and the high voltage issue inside the hub, where they have to wear special safety equipment, and the operator have to get a permit for the confined space. And this all results in a lot of high maintenance costs for the operators, technician time spent up there, battery replacement costs, and revenue loss for the downtime of the wind turbine. So we have been working with the operators for the past years, and they have approached us and said, hey, can't you come up with something that we can put in there instead of the batteries, because we are tired of just replacing batteries. We are tired of spending the time climbing turbines. It's a safety concern for us. And so we have created a drop-in solution for 2 different turbines. On the left you see one for the Clipper. It's a 2.5 megawatt turbine. It's a 400 volt system. On the right side it's a 54 volt system, a 1.5 megawatt turbine. And we basically designed a system that one has exact same form factor as a battery. The other one is a drop-in solution. You take the batteries out and you install it, and it will communicate with the existing SCADA system and the communication protocol. So we minimize the time for the technician to spend up in the hub. And there's no special training needed for the technicians who perform the work up in the turbine. And here are some of the benefits that the ultracapacitor technology has over the batteries, for example. So the retrofit that we have designed is designed specifically to last as long as you want to operate the turbine. So if you are in year 5 and you want to get 20 years, it will last for 15 years without any replacements. And while the batteries you have to replace, depending on the site where you are, you have to replace batteries every 2, 4, 6 years maybe. And then the temperature range, if you look at just the temperature range of the batteries, you have minus 20 degree to 50 degree. The ultracapacitors have minus 40 to 65. So if you look at very hot climate and cold conditions up north in Europe or in the US, Canada, Texas, or wherever you have, just because of the environmental temperature, you have very short life of the batteries. And so the retrofit basically will eliminate all the costs related to battery replacement and service costs. So if you are an operator, so you ask, okay, what are the benefits for me? And the benefits for me as the operator are increased reliability. My turbines keep running. I don't have to respond to battery fault conditions. And there's a reduced risk of collateral damages. I talked to some wind farm operators where they had the battery blew up, they had the pitch motor damaged, they had to rebuild the complete EPU, and that's a lot of cost, a lot of time spent, and for most, a lot of downtime for the turbine, and they lose the revenue. So now they are retrofitted all these turbines with ultracapacitors, and they improved their basically their uptime, turbine uptime, their revenue. And because the ultracapacitor can be fully discharged, I don't have to get the permit for high voltage condition in a confined space. I don't have lead acid gassing into a confined space. And before the technicians go in, they can discharge the ultracapacitors. They work at 0 voltage. And it makes life much easier and safer for the operator and the technicians. So if you look at the cost savings, and these numbers come from some of the wind farm operators that we work with, they compare the battery-related costs before and after they have done the retrofit. So they saved for service and replacement costs over the lifetime of the turbine, they saved about 47%. For labor cost, they are looking at 25% improvements in labor costs because the technician doesn't have to climb, doesn't have to check on battery faults, and doesn't have to go up there to replace batteries. The revenue generation part from the downtime, service time on batteries, they improved by 80%. And of course, these percentages will depend and are very site-specific, but it gives you a good idea of what the improvements are switching to ultracapacitor-based system. And this is pretty much what I had for you today. I would like to thank you very much for your attention. My email address is wbs@maxwell.com. You can come and talk to me afterwards if you have any questions, or send me an email. I'm happy to answer any questions. Thank you.